And tonight's Future of Everything. It's been a few days since we've talked about our favorite interstellar object, 3I Atlas.
What if I told you that right now, 93 million miles away, something is happening that could rewrite everything we know about visitors from deep space? You clicked on this video because you heard about 3I Atlas, but here's what you probably don't know. This isn't just another comet story. Harvard's top astrophysicist just announced that this mysterious interstellar object may have exploded into over a dozen pieces during its closest approach to our sun. But here's the question that's keeping scientists up at night. How does an object shed 4.4 million pounds of material per second when the math says it should be impossible? You're about to discover why the leading explanation for what happened to 3I Atlas challenges our fundamental understanding of what's possible in our universe, and why the December 19th close approach to Earth might give us answers that could change everything. Subscribe to Space Aquarius and let's begin.
Now we ask, okay, how much energy is needed to sublimate?
What we're witnessing isn't just another comet breaking apart. It's potentially the most dramatic interstellar event captured in real time, with jets of material stretching nearly 2 million miles into space. The energy required for this massive outburst defies conventional comet behavior. This isn't your typical space rock from our solar system. 3I Atlas has been traveling through the galaxy for potentially 10 billion years, carrying secrets from an ancient universe.
A surface area of an object that is 20 kilometers in diameter.
The scale of what happened near the sun is absolutely massive. Recent images captured by British astronomers Michael Buchner and Frank Niebling show something that shouldn't be possible for an object. We're looking at jets of material extending 620,000 miles toward the sun, and an incredible 1.86 million miles in the opposite direction. To put that in perspective, you could fit nearly 8 Earths end-to-end in that shorter jet alone. But here's where things get really interesting. Avi Loeb, the Harvard scientist who's been tracking this object religiously, ran the numbers. And they're telling us a story that challenges everything we thought we knew about comets. When 3I Atlas made its closest approach to the sun, called perihelion, it should have been losing material at a predictable rate. Instead, it went from shedding about 330 pounds per second in August to an absolutely staggering 4.4 million pounds per second. That's not a typo. We're talking about a 13,000-fold increase in mass loss in just a matter of months. Imagine a garden hose suddenly turning into Niagara Falls. That's the kind of dramatic change we're witnessing here. The energy requirements for this kind of outburst are mind-boggling. Loeb calculated that for 3I Atlas to naturally produce these massive jets, it would need to absorb 700 joules per square meter per second from the sun. That means the object's surface area would need to be at least 617 square miles, roughly equivalent to a sphere 14.3 miles across. But here's the problem. Previous observations from the Hubble Space Telescope suggested 3I Atlas was only about 3.1 miles in diameter. Something doesn't add up, and that's where this story gets really compelling. There are essentially two explanations for what we're seeing, and both are fascinating in their own right. The first possibility is that 3I Atlas completely disintegrated during its solar encounter. If the object broke apart into at least 16 equal pieces, though likely many more, it would dramatically increase the total surface area exposed to the sun's radiation. This would explain the massive jets we're observing and the incredible brightening that occurred during perihelion. If this fragmentation theory is correct, we should see the pieces separating over the coming weeks and months due to the sun's tidal forces. It would create a spectacular display, similar to what we witnessed with Comet Shoemaker-Levy 9 when it broke apart near Jupiter back in 1994. The cosmic fireworks we're seeing now might be the death throes of an ancient traveler that has wandered the galaxy for eons. But there's a second possibility that's even more intriguing. What if 3I Atlas maintained its structural integrity and didn't break apart? Loeb suggests this would mean we're dealing with something other than a natural comet. And when one of Harvard's most respected astrophysicists starts talking about non-natural objects, you know we're entering fascinating territory. The evidence supporting this alternative explanation is actually quite compelling. Consider this. Chemical rockets here on Earth achieve exhaust speeds of 3 to 5 miles per second. That's 10 times faster than the maximum speed we'd expect from natural comet material being heated by sunlight. Ion thrusters can reach even higher speeds of 10 to 50 miles per second. If 3I Atlas were using some form of advanced propulsion technology, it would require orders of magnitude less mass to produce the jets we're observing. This isn't the first time 3I Atlas has raised eyebrows in the scientific community. The object's trajectory is remarkably aligned with our solar system's planetary plane, something that has less than a 0.2% probability of occurring naturally for an interstellar visitor. When you combine that with the object's enormous inferred mass, over 1 million times more massive than the famous interstellar visitor Oumuamua, the statistical odds become even more extraordinary. Loeb calculates the combined probability of all these unusual characteristics at less than 1 in 100 million for a natural astrophysical origin. Those are the kind of odds that make scientists sit up and take notice. The timing of our observations couldn't be more perfect. 3I Atlas will make its closest approach to Earth on December 19th, giving us an unprecedented opportunity to study this mysterious object with our most powerful telescopes. The Hubble Space Telescope and the James Webb Space Telescope will both be trained on 3I Atlas during this close encounter, potentially providing the definitive answers we're seeking. What makes this moment in astronomical history so significant is that we're witnessing these events in real time. Unlike studying distant galaxies or ancient cosmic phenomena, 3I Atlas is happening right now, right in our cosmic backyard. Every day brings new observations and new data that could reshape our understanding of what's possible in our universe. The implications extend far beyond just this single object. If 3I Atlas did indeed fragment, it tells us something profound about the composition and structure of interstellar comets, objects that have been wandering the galaxy since before our solar system even formed.
We don't have a good enough image yet to figure out if
These cosmic time capsules carry information about the early universe and the conditions that existed billions of years ago. But if the alternative explanation proves correct, if 3I Atlas is something more than a natural comet, then we're potentially witnessing the most significant astronomical discovery in human history. The very fact that we're having this conversation, that respected scientists are seriously considering non-natural explanations, shows how extraordinary this object truly is. The beauty of science is that we don't have to wait long for answers. Over the next few months, as 3I Atlas continues its journey through our solar system, we'll gather more data, take more images, and conduct more spectroscopic analysis. Each observation brings us closer to understanding the true nature of this remarkable visitor. What do you think about this incredible cosmic mystery unfolding right above our heads? Try YouTube's new feature to hype this video. And leave a comment. I'd love to hear your thoughts on whether you think we're witnessing a natural fragmentation or something more extraordinary. Don't forget to subscribe for more breaking space news and share this video with anyone who loves a good cosmic mystery. The universe is full of wonders, and 3I Atlas might just be the most fascinating one we've encountered yet.